Hey Kipsters, it's Mr. Hambly. Yay! I'm going to teach you about proportional graphs. So the first thing, by the end of this video, you should be able to tell me if a graph is proportional or non-proportional. You should also be able to tell me if an equation is out of order, if it is proportional or non-proportional, and you should be able to define the word linear. So on the screen, there's 3 different types of graphs. And I want to identify that the red graph is a linear graph. And the reason why I know that is because it is a line. The other 2 graphs are this thing called quadratic. You're not going to learn about quadratic this year, but you need to know that there's other types of graphs besides linear. So let's just focus on linear. Right in the middle, between the 2 axes, is called the origin. We've learned that several times in 5th grade as well as in 6th grade. Now on your screen you have a whole bunch of different types of lines, 6 different ones. I want you to take a moment and I want you to identify what is the difference between the first set and the second set of lines. As you can see, the first few are proportional and the second are non-proportional. We know they're proportional because they go through the origin, or the 0, 0. The other ones don't go through 0, 0, so we know that they're non-proportional. So the orange one, the purple one, and the green one, or the blue one, the blue-green one, are non-proportional. So let's look at this as a graph. All the graphs we're going to learn about this year are linear. That means they're a line. If I separate those into 2 parts, they're either proportional or they are non-proportional. Another way to think about this is how we learned about rational numbers and real numbers, is that in the outer box, there's linear, and every linear line is either proportional or non-proportional. So if someone asks you, hey, I got this proportional graph, you can say, oh, that's proportional and it's linear. If they have a non-proportional graph, you can say it's non-proportional and it's linear. So I have 3 examples of equations that we need to examine just a little bit closer. Is this line linear? Yes, it is linear. Is it proportional or is it non-proportional? Well, because it has a y-intercept, it is not proportional. What is its slope? Well, its slope is -5, and its y-intercept is +8. The second one, is it linear or not? Well, of course it is linear. Is it proportional or non-proportional? Well, it's non-proportional because it has a y-intercept. The slope, many people think it's 350, but because it's first, but the slope is always attached to the x, so the slope is +2. And the y-intercept is 350. Next, is this linear or not? Well, of course it is linear. Is it proportional or non-proportional? Well, it's non-proportional because it has a y-intercept. What about its slope? Its slope is a -3.5, and its y-intercept is 0.5. Oh no, what did I do? 0.5. Alright, I want you to take these and do the next few by yourself. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right. Everybody wave. Bye.
Who's the best?
That will be a question.